think we are live. Hmm. Uh, yes, I think we are live. Mhm. Yep. So we are live. Hi everyone, and welcome to another session. We'll wait for some time for others to join in, but before that, let me just introduce myself. So we today we'll be learning about STL. This is the part of the data structures and algorithm series that I'm running. So my name is Soham Mukherjee. I'm a software developer. Currently, I'm working with Google, but before that, for 1 year, I've worked with Code Nation. I have been into ICPC regionals 2 times, 2017 and 19. I'm also a 6-star coder at CodeChef. What will I be teaching you here? I'll be teaching about web backend, React.js, system design, cloud services, and data structures and algorithms. So yes, if you haven't joined on the Telegram channel, make sure you join there. And if you're new to this channel, make sure you subscribe to the channel and hit the bell icon to be notified about any upcoming events or something. Also, if you're liking the content, make sure you like and share it with your friends so that it can help them as well. With that, we'll start with the agenda. But before that, good evening. Before that, I'll be just waiting for some time for others to join in. If anyone wants to. Okay. Any questions that you have? Hello, hello, Ayush. Any questions anyone has? I'm just waiting for others to join in. Good evening. Okay. I think many of you have already joined in, so we'll just begin with the session, and we'll if people want to join in between, like they're free to. But definitely, let me know if you have any questions for me before that. Then I'd like to take up some questions. And yes, hi Venkata. I'd like to take up some questions, and then we can actually start with today's class. Let me just get my writing pad. Yes, and whiteboard. Cool. And also I need my writing pen. Please make these sessions regular. So Repaka, I don't know if Lokesh, I don't know if you know about this, but the channel will be paused for some time. By this month, 31st is the last date. After that, it will be paused. So I'm not sure when it will be resumed back, but definitely it will be paused for some time. So there's nothing called regular right now, right? So means we cannot be regular definitely. Good evening, Tathagato. I'm just waiting for the whiteboard to start. And meanwhile, if you have any questions for me, please feel free to ask me. Or otherwise, why the pause? Just asking. I'm not sure about the entire reason, but something maybe related to business or something. So yeah, you can definitely wait for their official announcement of what has happened. But yeah, priority queue and heaps are same. Yes, yes, yes. Start from beginner level, please. Let's see. Definitely, I have already discussed about stacks, queues, and I'm pretty sure that you already know about. I've also discussed about linked lists as well. So I'm assuming that you already know about arrays, linked lists, stacks, and queues. And from there we'll start. Venkata will make some arrangements. Let's see. Let's see. We'll make some arrangements definitely, but yeah, for now it will be definitely paused for some time. Anyways, let's continue with the class. So first thing, today we'll be learning about STL, right? So what is STL? STL stands for Standard Template Library. I think everyone or most of you know about this. Now, this is known as STL for C++. However, there is collections for Java, or there might be other things for Python. So there might be similar. Actually, there's no name, I believe. But again, like there can be similar libraries for Python. So different for different languages, STL is just a name with respect to C++. That's why we are using it. But again, we'll discuss the concepts in a general way, will not be specific to C++. Yes, when we write code, we will go specific to C++, but we'll discuss all the concepts in more general way. We'll try to discuss them in more general way, but definitely, like, let's see how we can go. Where to apply in CP? Yes. That's the like agenda. Like that's what I'll be trying to cover today. But before that, let's actually, like, before we understand when to use what, let's first understand what each of them does. Like what are the properties of each of them, right? So each of the STL that we have. So what are STL? STL generally, like when I'm talking about STL, I'm talking about the containers, right? I'm not talking about the algorithms that are there in STL. So STL is a contains some iterators, some containers, some algorithms that are there. I'm mostly talking about the containers, right? When I'm talking about STL, so there are multiple containers that are present. So what are containers? Containers basically mean they can hold some data, right? They can hold some data, but they have some specific properties by which, like, they satisfy some properties to be holding that data. Two of the STLs we have already discussed about, that is stacks and queues, and we already know about what is the use case of stacks, when should we use stacks, when should we use queues, and we know this, right? The third STL or the third container that we have is a DQ. So first of all, we'll start with DQ. So what is a DQ? A DQ is a double-ended queue. It's a double-ended queue. What do we mean by this? In queue, we know that if we are inserting from one end, we are removing from the other end, right? Or the other way around, like we can definitely like do the other way around. Sorry. This screen is lagging a bit. But yeah, we can definitely do this like this as well. So in queue, we know that we are inserting from one end and we are removing from the other end. But we have something called a DQ, that in which we can insert from both ends and we can remove from both ends, right? We can insert from insert from front, remove from front, insert from back, remove from back. We can insert from both ends, right? So that's why it is called a double-ended queue. Kind of, it looks like a double-ended queue, like it's a queue from this side as well, it's a queue from this side as well. So that's why the name is given to this. Now what are the properties for this? The properties being that, first, we can insert any element at front. So insert at front or back. If you are inserting any element at front or back, it will take a order of one time, that is a constant time. Second is, if you want to remove any element, right? Remove at front or back, remove any element from the front or the back, it will take you a order of one time. But there is downside as well. The downside being, if you want to insert any element at any position, right? So insert an element, general insertion, right? If you're inserting an element at any position which is not front and back, it will be order of n time. Any other position, it will be approximately order of n time in worst case, right? Similarly, if you want to delete any element, not the front and the back, delete any element, it will be order of n time in worst case. Like it will be similar to what you do in queues or arrays, the same thing, right? The only advantage that you get out of this, like which is not there in queues or arrays, is that you can insert it both front and back, you can remove at both front and back. So that's basically a DQ. We'll look into like what can we do with the DQ, like what are the problems that we can solve with the DQ in some time. But generally DQ is not, I wouldn't say DQ is very important, right? I wouldn't say DQ is very important because it just solves some specific problems. Like generally we just use DQ for just solving like sliding window, minimum, something like that, like finding minimum in window size of k, and we'll look into that as well, minimum or maximum rather. but DQ does not have a lot of use case, right? So that's basically about DQ, and we'll look into the problem in some time. Just remember these properties, that insert at front and back is order of 1. It will take order of 1 time to insert. Just think about DQ as a double-ended linked list, right? Or double, like you store both the head and the tail, so you can insert both at front and at back as well. So it's just, and it's a double-ended linked list. Just assume that everyone has a next node and a previous node, like normal linked list, right? So it's a double-ended linked list. So just or double sorry, not double-ended linked list, doubly linked list. So that's how a DQ will be implemented, right? So it's easy to insert at front and back in order of 1 time, remove as well at front and back in order of 1 time. But if you are inserting at any general index, like you are telling that insert in nth position, right, where n can be anything, so that will take around order of n time. Generally it will take around order of n by 2 time, because you can, like, whichever is the shortest way, the front or the back, you will just go from one direction, from that direction, and generally it will take around worst case order of n by 2 time, but that's eventually order of n. Similarly, delete of element is as well order of n, right? So that's basically our DQ. Let's move to the next one. We'll not discuss a lot about this. We'll definitely solve the problem that it solves, the sliding window maximum in K, like sliding window maximum, but that will solve in some time. Okay. For now, let's just focus on the other ones, and we'll try to compare, like we'll try to understand when should we use what. That's the main concern, right? That's the main question that we have. If we have these many tools, if we have these many containers, when should we use what should be the identifier that we should look into, that we can identify that for this problem I should use this one, for this problem I should use this one. That is what we'll try to establish. Okay. Let's go ahead with the second one, that is set, right? We'll go ahead with the second one, that is set. Set is another container that is there. Now it is a very important container, right? It's a very important container. Why? Firstly, it stores the data in ordered fashion. It stores the data in ordered fashion. That is, if you insert into a set, if you insert, let's say this is a set, if you insert 1 2 1 and 3, and after that you insert 2 to this, if you are inserting 2 to this, it will be storing it in the same fashion, 1 2 3, in the ordered fashion. सैटरडे को लाइव है, सैटरडे को रिएक्ट का लाइव है, ठीक है? रिएक्ट का प्रोजेक्ट करेंगे कल कुछ। आज STL का है। STL का ड्यू है था एक्चुअली पहले पिछले वीक का, बट कुछ रीजंस के लिए नहीं हो पाया, तो हाँ आज है। ओके, सेट इज स्टोरिंग थिंग्स इन अ ऑर्डर्ड फैशन, ठीक है? Ordered fashion का मतलब क्या हुआ कि it will always be storing things in a sorted way. Like if you are traveling through the set, if you have inserted, let's say 5 elements in normal, like in any way, right? Let's say 1 3 2 5 ऐसे कुछ, like या 5 1 3 2 ऐसे कुछ randomly insert किए तुमने। जब तुम travel करोगे set पे, you will always get it in a ordered way, 1 2 3 4 5. It is always in the ordered fashion. It always stores the data in ordered fashion. That is the yes, I'm coming to that. That is the first property of a set, right? The second property of the set, which we can tell that it actually hinders in some of the problems as well, is that all the elements will be unique. It only stores unique elements. It only stores unique elements. That means if you are inserting 2 2 2 into the set, it will just store one occurrence of 2. It will not store all the occurrences of 2. First thing, it will store everything in an ordered fashion. Second thing, it will store only unique elements, right? It will only store unique elements. Third is, now we'll come to the important parts. The third is insertion. If you are inserting any element into the set, if you are inserting any कुछ तो प्रॉब्लम हो रहा है, रुको। If you're inserting, right, if you're inserting any element into the set, it will take order of log n time, where n is the number of elements in the set. So insertion, any element you are inserting, लाइक इसमें पोजीशन का कुछ बात नहीं होता, कौन सा इंडेक्स पे इंसर्ट कर रहे हो, यू आर जस्ट इंसर्टिंग एन एलिमेंट. लेट्स से यू आर इंसर्टिंग 2 into the set, so it will take order of log n time, where log n is the number of elements currently in the set. तो जितना एलिमेंट सेट पे है उसका लॉगरिथमिक टाइम लगेगा टू इंसर्ट एन एलिमेंट, राइट. सेकेंड थिंग इज डिलीशन. If you're deleting an element, it will take order of log n time. Again, if you're deleting an element, it will take order of log n time. Fifth is finding. If you want to see if an element is there in a set, it will again take order of log n time. Finding if an element is there in the set, is 2 there in the set, is 5 there in the set. To find these elements, it will also take order of log n time, where n is the number of elements in the set right now. Lastly, deletion with iterator. What is iterator? Iterator means, okay, so in STL we have containers, right? We have containers. It also provides us with something called iterators that helps us iterate on these containers. Like, let's say you want to see, a set is not an array, right? A set is not implemented like an array. A set is implemented like a tree. A set is implemented like a tree. So how would you travel on the set, right? For that, you cannot travel on it like an array, right? So to travel on it, you are like C++ also provides you with iterators, right? It will provide you with iterators. Iterators, you can think of it like pointers, similar to pointers, with some methods. Obviously, you have some methods available. With iterators, you can iterate on the containers, right? You can iterate on the containers. Now, iterator basically kind of it's very similar to a pointer. It will, like, you can treat all of the elements that are there in the set as nodes. Now, if you have the iterator to one of the elements, that is, if you have the pointer to one of the elements, then if you want to delete that element, it will be order of 1. It will no longer be order of log n. Deletion when you have a iterator to an element is order of 1. Just remember this, right? What are iterators again? If you want to travel, like if you want to travel on a tree, you cannot just travel similar to an array, right? You cannot do I plus plus, I equals to 0, I less than, and I plus plus, right? You are traveling on a tree, so there should be some way you should be able to, you can do that. So what C++ provides you with is iterators that will help you travel on these containers easily without, and with a very similar syntax that you have with respect to like arrays, right? With a very similar syntax, you will travel with like you will have a very similar syntax, right? So with iterator, if you have a iterator to an element, and if you want to delete that element, it will be order of 1. Just remember this is very important, ठीक है? तो आइटरेटर होगा एंड फिर तुम डिलीट करोगे तो ऑर्डर ऑफ 1 बन जाएगा. नहीं तो अगर नॉर्मल डिलीशन करोगे तो इट्स ऑर्डर ऑफ log n, right? If you want to normally delete, it's order of log n. If you have an iterator, it will be order of 1. तो इसका थोड़ा एग्जांपल्स देखेंगे हम लोग, ठीक है? We'll look into a few examples for how do we create a set, and how does these operations happen. So let's just go ahead. I don't want to know what's new. Okay, let's create a new file here. What do we call it? We call it stl.cpp. So whenever you're using STL, you have to use the corresponding library. Definitely you have to import the corresponding header files. Like, let's say you are using a vector, you should import hash include vector, right? But again, you have bits stdc++.h, which actually includes everything. So just use bits stdc++.h, right? So bits stdc++.h using namespace std, and we have int main. So how do we create a set? We write the keyword set. After that, set is a template, right? It's implemented as a template. So template means when the type that you have, the type of data that you are storing, it is not defined earlier, right? It is defined at the runtime. When you are creating a set, you define what is the type of data you want to store. Do you want to store a string? Do you want to store an integer? Do you want to store floating point values? Do you want to store a structure? Whatever you want to store, you define so that's why you need templates. Like, you define the type of the data that you are storing at runtime, not at compile time, right? Generally, when we define variables, how do? We do like this, like int x, you already define the type of the variable, right? But with templates you can define the type at runtime. That is when you are actually not at runtime, actually when yeah, maybe at runtime you can define it as runtime, right? But again, like it's the type is not fixed. Basically the type is not fixed, that it's not telling that you have to create a set of type integer. You can create a set of type string, you can create a set of type any other type, right? So that's why we use templates. Like if the type is not fixed, like let's say you want to find maximum, right? You create a function called maximum. Now what do you want the maximum of? Maximum of integers, maximum of floating point numbers, maximum of some other thing, right? Maybe maximum of strings. What do you want the maximum of, right? So in that case, maximum should be a template function. It should not be normal, like you should not override it for all the definitions. You should create a template out of it and then take care of whatever is the type. Based on that, you just correspondingly do anything, right? So set int will create a set int and let's call it x, right? So how do we insert into x? X dot insert. We have the dot insert that will help you insert, and this is log n time, right? This will take log n time. Log n. Remember, this will take log n time. X dot insert. Let's just insert a few more things. So x dot insert 1, x dot insert 2, x dot insert 5, x dot insert 4, x dot insert 1. Let's say we have inserted these things, right? So all the insert operations will take log n time. Now what we can do is we can try traveling on this set. How do we travel on this set? We can do it in multiple ways. One way is you can write a for each loop. You can write a for each loop like this: for int x, for int v belongs to x, like this. So you are traveling through all the values that are there, in this set x. You are traveling through all the values one by one in this set x, right? So you can write a for each loop like this, definitely, but we will travel using an iterator, right? So how do we define an iterator? Generally we can define it like this: set int, whatever is the type of the iterator that you want, iterator, you give it a scope resolution. This is called scope resolution. Iterator, that is, the iterator is of type set integer, so it will bring a iterator of the set integer class, set class. It equals to x dot begin. So begin returns an iterator to the first element, right? Begin will return an iterator to the first element. How long will you travel? It not equals to x dot n. N returns an iterator after the last element, not at the last element. It will return an iterator after the last element. So you do not go to end. End is not there. End is the space. It's pointing to a memory location that is not there within your set, right? It's after the last element. And it plus plus, you can just go ahead with it plus plus, although it looks like an array, right? Although it looks like an array, that it plus plus मतलब similar to I plus plus, so array जैसा ही हो रहा है, नहीं हो रहा है. It plus plus is because it is overloaded, right? Set int iterator हमने use किया, right? We have used set int iterator, so it has just overloaded the definition of plus plus for this set int iterator, right? Or the set class. It has just overloaded the definition. So it plus plus doesn't mean it equals to it plus 1, right? Or it does mean it equals to it plus 1, but again, like the meaning is different. It's completely different, right? It just goes to the next node. Not yes, we can use auto as well. So in case you don't want to write this much, right? If you don't want to write this much, that it's a set int iterator, obviously this is a good coding practice. You should always try to write the appropriate data type. But again, when you're doing competitive programming or when you are solving problems in a live contest, you don't have that much time that you write like this every time, right? So a shorter way can be either you can go for a for each loop, or you can write auto like this. Auto will automatically take the type. So it will just evaluate. Auto means it doesn't have a type yet, it will automatically be typecasted. So it will take the right hand side. Okay, right hand side we have a set int iterator, right? So this auto should be set int iterator. Like this, it will automatically typecast. So let's just go ahead with this. So see out value at it. So it is very similar to pointers, I said, right? So similar to, just assume that you have a pointer and you are doing wanting to print the value at an element, right? So what do? star value at operator, you use the value at operator. So similar to that, we are also using here also the value at operator. So it's very similar to a pointer, although this value at operator is overloaded. Definitely it's overloaded, right? Okay, so we have value at it, and after that let's give a new line. What we'll do is we'll now delete an element. We'll first find an element. Definitely okay, we can find an element definitely. How do we find an element? Cout x dot find, right? X dot find, what does it return? It returns a iterator. See, it returns a iterator, right? So x dot find, what I'm finding, just write the element that you want to find, 2. So it will return an iterator to the 2 if it is available, right? If it is not available, it will return an iterator to the end. So if you want to see if an element is there or not, you can just check like this: x dot find 2 not equals to x dot end. That means the element is there, right? That means the element is there. So let's give a slash n after this. And in fact, just keep this as well. Okay, in fact, you also can do a lower bound on set, right? You can also do a lower bound on set. What is the definition of lower bound? Same thing, right? The first element, it will give you a pointer to the first element that is greater than equal to the value that you have specified, right? So you can definitely do a lower bound as well, and that is also very useful. Just remember that you can do a lower bound as well on set. Okay, x dot find. Now what we'll do is we'll remove an element. So x dot erase 2, we are removing 2, right? After that we'll again do the same thing, cout x dot find, right? We'll do the same thing here again. So let's just do this: cout x dot find, copy paste. Okay, so what should be the output? The output should be what we have done first. We have inserted 2 1 2 5 4 1. So what should be the output for the first, like after inserting, if we are iterating through all of them and we are printing, what should be the output here? Anyone? What should be the output here? 2 1 2 5 4 1. We are inserting them in this order: 2 1 2 5 4 1. What should be the output? Pretty simple. Batao. I'm pretty sure most of you already know about this. So bata do. 2 1 2 5 4 1 is the order may we are printing all the elements one by one. So what should be the output? Okay, Ravi is telling 1 2 4 5. Saurav is telling 1 1 2 4 5. Okay, let's see what's the output is. What the output is. Let's see. Chalo. Time लगेगा run करने. It's running. It's running, I believe. Okay, we have. So 1 2 4 5 is the answer. Why? फिर से why is 1 2 4 5 the answer? देखो second point क्या था इधर? Unique elements will get stored. It will only store unique elements. So if you are inserting two times, 2 times, it doesn't matter. It will just store one occurrence of each of them. So 1 2 4 5. Now what we have done here, we have deleted, and this also proves that it actually stores one occurrence, right? We have done here x dot find 2 not equals to x dot end, and we have got 1 here. 1 means true, that is it is there. 2 is there, indeed 2 is there, right? In the set 2 is there. After that we are erasing 2, and then when we do dot find, we see that 2 is no longer there, although we had inserted 2 2's, right? We had inserted 2 2's, so it's not there. So definitely it stores unique values, it stores unique elements, right? Now coming to the last point, that is, if we have an iterator to an element, then we can delete it in order of one time. So what does that mean? If I just do like this, that I just get an iterator to this element, right? So auto it equals to x dot find 2. I just get an iterator to this element, and instead of running x dot erase 2, definitely you can run this, but this is order of log n, right? This is log n time. you are erasing an element. But now I have an iterator and I want to erase that element, right? So x dot erase, I can in erase I can pass an iterator as well, x dot erase it, and I can take an iterator as input. Like from this it will also return an iterator to the next element. If you do like this, it equals to x dot erase it, it will return an iterator to the next element, right? So we can in fact do cout value at it, and we should get 4, right? After 2 4 comes, so we should get 4 ideally. So let's see if we are getting 4. And definitely we should also try to print all the elements that are there, so let's just do that as well. So we'll do print all the elements that are there. So let's just print all the elements that are there. So we have done that, and let's give a new line here as well. Okay, so that this is basically what it means, right? X dot erase it, you can pass an iterator and it will delete the element at that iterator. So let's just run this again and see what we get. So what are we getting? It's taking some time to run. Let's just wait for it to run. Okay, 1 2 4 5, right? So 2 got deleted. What did we do here? See, it equals to x dot erase it and cout value at it. So 2 is deleted, x dot erase it, 2 is deleted. When it is deleted with an iterator, it returns the next iterator, right? It returns the next element iterator, that is it will return an iterator to 4. So that's why we are getting 4 here. Now if you when we print it again, 2 is gone, so 1 2 4 5 is what we have left. So that's basically a set. We'll understand when to use set, but before that let's discuss about all other containers that we have, and then actually we can have a fair discussion on when to use set and when to use the other of them, right? So that's there. Okay, let's just discuss that later, like once we're done with all of them. So the next thing that we come into is multiset. Multiset. It just solves one extra problem that was there with set. That is, multiset is similar to a set. It's same as set. The only difference is that the uniqueness constraint is not there. So uniqueness constraint, that is it will only store unique elements. This constraint is not there. Other than that, it is same as set. It will do the same things as set. Only the fact is, if you want to store multiple occurrences of an element, you should use a multiset, right? You should use a multiset. So how do we create a multiset? Same way, I'll not modify the code at all. What I'll do here is I'll just rename this to a multiset now. Let's see what happens. Let's create, instead of set, we'll create a multiset here. I'm not sure if find will give something. It should give the first occurrence, but let's see. I've just created a multiset here, right? So let's just try to run this and maybe clear the console and run this. Let's wait for it to run. Okay, so we still have one second. Have we created? So we haven't saved, I believe. Let's just run this again. Can you paste the code in chat box? Chat box, it will be difficult. I'll just paste. Maybe I'll paste. I don't think you'll need these codes because these are available. But definitely, if I do some problems, I'll definitely paste the code in or push the code in GitHub. I'll do that. Okay, GitHub ka link you'll get in Telegram. Chalo, 112245, right? Now see, we are storing 212541. It's stored in the ordered way 112245, but all the occurrences of each element is there. Now you are finding 2. What will it return? It will return the first occurrence of 2. So when you are deleting 2, when you are doing x dot erase it, it will remove the first occurrence of 2, and then it will return. What will it return? It will return the next pointer. What is next value? Next value is 2, a pointer to the next value. So an iterator to the next value. So the next value is 2, so that's why we get 2 here. And after that, if we print out the 11245. In fact, if we just do a normal erase, right, x dot erase 2, what will it do? It will just erase the first or one occurrence of 2, right? It will just erase one occurrence of 2. We can actually verify it here as well. Like, let's just wait for it to complete. Okay. No, it erases all occurrences of 2. You have to do find then. To erase one occurrence, you have to do find and then erase, right? You cannot erase like that, or you have to use iterators and then erase. Otherwise, for erase, it will erase all the occurrences of 2. I think there is a method to erase one occurrence, but you can definitely check it out. सबका documentation मिल जाएगा. How to check them out? You should definitely go to cppreference.com. This is the best place you can actually go to, like CPP reference. And here you'll get the documentation for all the C++ standard libraries that you have, or C++, in everything about C++, right? So this is the best site that you can refer to for all the documentations or all the APIs like that are there. And do give a read about all of them and see what it has, right? So that's there. So that's about a multiset, right? That's multiset. So what is a multiset? A multiset is a set. It's everything that a set does, but only difference is the uniqueness constraints will no longer be there. That is, it can store multiple elements with the same value. It can store multiple elements with the same value. That's a multiset. Now I'm not discussing about unordered set, right? So whenever we come across a data structure, like let's call it set or a map, we will get a corresponding version of, so we'll get unordered map and we'll get a map, or a set and a set, unordered set and a set, right? Similar to this, we'll even get the same thing, I think, in Java as well. We get tree set, we'll get hash set, right? We'll get tree set and hash set, right? So we'll get the two variants, right? The two variants, why do we have two variants, is because the second implementation is a tree. The second implementation is a tree. That's why we have a log n complexity, right? For all the insertion, deletion, everything. The first implementation, unordered implementation, is a hashing implementation. It's a hashing based implementation. So everything like finding element, inserting, deleting, everything is actually order of one, right? So unordered map, everything is order of one, but it's order of one in probabilistic way. If there are no collisions, then it's order of one. If there is lot of collisions happening, then it's no longer order of one. So that's why it might even shoot up to order of n if the test cases are designed in such a way. So it's always safe to use a map instead of an unordered map. But again, like, it depends on what are you doing. If you're sitting for a big contest and you see that you can actually use a map, like you can actually afford a log n complexity, then definitely go for a map. But if you're like, maybe if you're sitting for an interview or those things, you can definitely go for an unordered map, because you can just tell that it's hashing, it will take order of one time. There can be collisions. If there are collisions, you can just use a map instead, right? So definitely you can do that. But again, like, it depends. If you can support, I would say, whenever you're doing a contest, if you're giving a contest, if it supports a map, if the constraints support a map, just go for a map. When does the constraint support a map? When you can have a n log n complexity overall. Like, n log n means if you have around 10 to the power 6, n log n will work, right? It will be around 20. So 2 into 10 to the power 7, which is good. But if you have n around 10 to the power 7, right? If you have n around 10 to the power 7, n log n might be very costly. So just think about this. If you can use a map, in most cases you can, but if you cannot, in those cases you should go to unordered map or unordered set, right? Those variants. I'm not discussing them in detail. They are the same thing, only the implementation is different. So I'm not discussing them in any more details. Like, I don't think anything else is needed on that. Let's just go ahead with a map. Right. My system is lagging terribly. Okay, we are here. Okay, let me know if you have any doubts till now. Anyone has any doubts till now? Otherwise, we'll continue. But let me know if you have any doubts till now. Anyone has any doubts? Okay, no. Good. Let's go ahead then. The next thing that we'll look into is a map, right? Now we have map, we have unordered map. I'm not discussing about unordered map because we already know what is the difference between a map and an unordered map. We have already discussed that. Can you discuss maps concept? Yes, I'm discussing about maps now. What are maps, right? What are maps? Maps are basically associative data structures, right? So if you want to do something like this, that so what do we do actually? Multimaps, can we say multimap is similar to min-heap? Multimap is similar to min-heap. Is it similar to min-heap? I don't think multimap is similar to min-heap. I have to check once. Okay, I have to check one. Is it similar to min-heap? I'm not sure. Because we have a different implementation for min-heap altogether. Let's just see once what. Uh, C++ reference. Value. Let's just go to gigs or gigs and find it out. What's the multiple elements can have same keys. Why should we have a multi-map? I'm not sure what's the use case of a multi-map, but I don't think you will definitely need multi-map anytime. Like anytime you'll need it. I never needed. What should be the use case of multiple keys? Not sure. Maybe you might need it, but I'm not sure what's the use cases here. Anyways, map and unordered map. So it's an associative data structure. What do we mean by associative? So what do we generally do? We prefer writing like this, right? A of 0. We prefer writing like this, right? Let's say we have student records, right? We have student records. There are n students with us. There are n students with us. What does the student each student contain? So let's say we have a student type that is there, student type. What does it contain? It contains the name of the student, it contains marks, it contains some other details. Let's say these two are there. What we want to do is we want to create a system. Where we are giving, like we are giving a search box where the person can enter the student name. The person just like gives the student name, and given the student name he will get the marks for that student. Like say an exam is over, so he will get the corresponding marks of the student. I'm not talking about a database level design or there will be a database involved. Just a simple question: given student names, you have to print the marks of the corresponding student, and you have to do this in an efficient way, right? So definitely there are multiple ways you can definitely travel through all the students, compare their names, and then tell that this student has this marks. Definitely that's a solution. But okay, let's understand this. If we were given this question, instead of given this, if instead of double pointer with node or a pointer and reference with a node, why do we need a double pointer with node? Which node are you talking about? Which node are you talking about? Not sure what you're talking about. Are you talking about a tree or something? Not. Okay, I'll come to, like, just type in whatever question. I'm not clear about your question, but Acha, are you talking about why do we need something like this in star star? Are you telling that this one in star star or something like this? Why do we need this? Okay, node start star. Yeah, got it. That because it's a pointer of a pointer, right? Like a pointer. So if you want to pass a reference of a pointer or a pointer of a pointer, references or pointer, that means that, okay, let's understand. So if you have a pointer like this, right? Let's call it. Let it have a value of 100, and let's say this will become. It is stored at memory location 1000, right? Now what you are actually doing is you are in your code, you are actually modifying this to some other memory location. Like let's say you are maybe doing some operation, and this head will be getting updated, right? So if you are not passing a reference, passing a reference because you do not return anything, it's a void function, right? If you are returning something, you can just assign that to that. Like just assume that you will just assume that you have a linked list and you will remove from the head of the linked list. So the head is updated, right? The head will be updated. So what do you call? You call like this, remove head. Now if you return an updated head from the function, then you can do it like this, right? Head equals to remove head. Okay, but if you are not, if you are having a void type function, you want this head to be updated in place. In that case, let's say the head is pointing to this, right? Head is pointing to this. Now what does head mean? Actually, head is a pointer. So this head variable, the variable is stored in the stack memory. In the stack memory, it will be stored as head, head with some, like let's say head, and it will contain the memory location 1000. It will contain the memory location 1000. That in 1000 location this data is stored. If you don't pass a reference to this, now the head, let's say the next element is at 2000, the head should be updated to 2000, right? How would you update this head's value to 2000? For that you need to pass a reference, or you pass a pointer to this value, right? Reference or pointer, right? So that's why you can directly, when you now do, like if you update the head in the function, if you are updating the value of the head, it is actually reflected in the calling function as well, like because you are directly changing the value here, like you are updating this value directly here to 2000. That's why you pass a reference or a pointer to that node, right? Okay, let's come back. So we have the student name and we have marks, like right, the people will be entering the student name and they will get the corresponding marks, right? Let's say I will just modify this problem statement a bit. What I will tell you is, given index I, can you tell me the marks of the ith student? Given index I, can you tell me the marks of the ith student? You can definitely do that. You will tell, hey, I will store all the students in an array, then I will just do like this. Let's say students array is like this student, you will just do student I dot marks, right? You will just print this thing. So definitely this is easy, and this is the order of one time. It will take order of one time to do, and it is very easy to code. But now the problem is, you are given the student name, you are not given the index I, you are given the student name and you want to tell the marks, right? Now the problem here being, you can tell, hey, can't we not use the same thing? Like, can there be a something, let's say an array, if we can store it in an array where the name is the index, and it will contain the marks of the corresponding student. The name is the index, or the ID is the index, the student ID is the index, and it will contain the marks of the corresponding student. If we have such a data structure, that will definitely help us, right? If we have such a data structure, then you can just write, you can just do cout a of name, like that. But the problem is, name is a string, right? Name is a string, it is not an integer. So definitely you cannot use the name as an index, as an array index. You cannot use that. For these reasons, we have associative data structures or maps that will help you store key value pairs, so that you can easily access them like this, a of key, and you will get the corresponding value associated with this. So these are maps or key value pairs. So if you have some problem where you have to store, like given student name, how many times this student, like what is the total score of the student, or those things, definitely you cannot have them, you cannot store the names as indexes. So you should use a map so that you can use the names as the keys, right? So that's a key value pair store. So that's basically why we need maps, right? Why we need maps? Because the problems always will not deal with, like it will not always be given index find the value, because this is a very real example. You are given the student name, you have to give the marks. This is more realistic than given the student index find the marks, right? So that's why we need such key value stores, and these should be fast. These operations should be fast, right? So let's talk about maps. What are the complexities that are there with the map or unordered map? So for maps, One, insertion. Insertion into a map is order of log of the size of number of elements in the map. So order of log n, right? For unordered map, it will be order of 1, right? For unordered map, it will be average case or order of 1, worst case order of n. Deletion. If you are deleting a key, from the map, order of log n, again, number of elements. Getting value, or let's call it retrieve operation, right? Let's call this retrieve operation. So retrieve, it will be order of log n again. But these all operations will be order of 1 in unordered map, right? In unordered map, it will be average case order of 1 and worst case order of n. All of these operations, right? Because there might be chaining and those things, right? Difference between a ordered and the unordered map, I've already discussed that. But again, ordered map means it will be implemented like a tree. It will be implemented like a tree. Unordered map, it will be implemented using hashing. We know that hashing is a probabilistic algorithm. So all these complexities that you are seeing, are deterministic. It will never be worse than log n. It's worst case log n, right? It's deterministic. But hashing is a probabilistic algorithm. So there is chaining and those things that might come in. So it's average case. We can tell that average case is order of 1. In most of the cases, it will be order of 1. But if you are given a test case where it will lead to chaining, in those cases it can be order of n. It can shoot up to order of n as well. So that's the difference between a ordered and an unordered map. Ordered map, it is always within log n. It doesn't depend on the input. Unordered map, it will depend on the input that is given. It can be, in most cases, it will be order of 1 each of these. In worst case, it can be order of n each of these operations. Okay. It's a probabilistic algorithm. Hashing is a probabilistic algorithm. So we have insertion, deletion, and retrieve in order of log n time. Okay. We have these operations in order of log n time. Chalo. That's about a map. We'll look into a map as well. Let's just look into some or let's just keep that. Like I'll maybe whenever we solve the problems, we'll look into maps, how they do. And also like the keys, it's ordered with respect to keys. Remember this, it will be ordered with respect to keys. That is, if you're traveling on the map, it will be in increasing, like whenever you're inserting into the map, it will be storing all the values in increasing order of keys, right? So it will be ordered with respect to keys. Let's go to the final one, that is priority queue. Priority queue, or we can call it a heap as well. Like a general term is a heap, right? So priority queue or a heap. What is a priority queue and a heap? It's what it does is you can get the maximum or minimum element in logarithmic time. The maximum or the minimum element in logarithmic time, only one of them depending on the implementation of the heap. It can be a min heap or a max heap. If it is a min heap, you can get the min element in order of log n. If it's a max heap, you can get the maximum element in order of log n. Not both of them at the same time. You can insert any element in order of log n time. You can remove the top element. You can remove the top element in order of log n time. However, you can remove any element. If you want to remove any element, it can be worst case order of n time. It can be worst case order of n time. Okay. So, एक सेकंड रुको सर, कैन वी ऑर्डर द मैप अकॉर्डिंग टू वैल्यूज नॉट कीज इफ पॉसिबल? वैल्यूज नॉट की, आई डोंट थिंक इट इज पॉसिबल. लाइक it has to store them in an ordered fashion with keys for easy searching. So yes, it is ordered with respect to keys. Okay, it's not ordered with respect to values. Anyways, priority queue or heap, you can find the maximum or minimum element in log n. You can insert in logarithmic time. You can remove the top element in logarithmic time. You can remove any element in logarithmic time in order of n time, right? Any element in order of n time. Just remember this. If you want to remove any random element, you have to use get an order of n time. But if you look into this properly, these are all the things that actually a set can do, a map can do. All these things a set and map can also do. And in fact, you can remove any element from them in much better complexity. So why should you even use a priority queue, or why should you even use a heap? That is because all the complexities that I'm talking about here, they are some C into log n. They are some C into log n, where C is a constant factor that is hidden. This is called the hidden factor. This hidden factor, it is much less in heap compared to set or a map. So in some problems, if you use a heap, it will actually pass, but it can give time limit exceeded whenever you are using a set or a map. Although a set and a map can definitely replace a heap, but this C factor will be high, so you might get a time limit exceeded because of this. So you might have to switch to heap. Okay. So definitely, if you have a problem where you can use a heap, you should definitely use a heap. If you have some problem where you cannot use a heap, you will not use a heap. As simple as that, right? So it's not that you should give preference to set or a map over heap. Definitely not. So let's now come to the main important topic, that is when to use what. That's the main question I'm pretty sure each one of you have. Let's take a few scenarios, right? Let's take a few scenarios before we discuss when to use what. But before that, let me know if you have any doubts. Let it clear the canvas. Meanwhile, let me know if you have any doubts. Just give me a second. Let me know if you have any doubts. Just give me a second. I'll just be back. Okay. Okay, back. Let me know if you can you guys hear me? Can you guys hear me? Let me see. Okay, yeah, I think you guys can hear me. Is there any doubt? Is there any doubt with whatever has been done till now? Do you have any doubts? Anyone has any doubts that we have covered till now? Let's go ahead and then. Okay, audible. Awesome. Let's go ahead. Okay, when to use what, right? When to use what? Let me just give you a couple of scenarios. Let's say the first question, right? You will be telling me what to use. First question, uh, what you have to do, like these are the operations that you have to do in the problem. You have to insert elements. You have to insert elements. You have to report the maximum element. You have to delete elements. What should you use? You have to insert element. Is priority queue present in other coding languages? Yes, it is also present in Java. It's present in Java. It's implemented as a linked list, I believe, but it's there in Java, definitely. Anyways, linked list as in it's a part of the linked list class. So when you do new priority queue, priority queue equals to new linked list. I think you do something like that, but it is definitely there, right? Heap is definitely there. These are the operations that you have to do. Insert elements, max, you have to report the maximum element, and you have to do delete elements, right? Assume that there are multiple queries and each query can be of these three types. You can insert element, you can you have to report the max element, and you have to delete elements. What should you use? What should you use? Insert element, max element, delete element. What should you use? Anyone? You are inserting elements, finding the maximum element, and deleting elements. What should you use? What should you use? What are you using in this? Just remember the properties. Unordered set, heap. Okay. So again, Dharavi is saying heap. Arshad and Totagata are saying set or unordered set, right? Versus heap. So set versus heap. Set versus heap. Let's understand, right? Insert elements. Insert elements, both of them will support. Finding the maximum element, both of them will support. Maximum element in the set is the last element, right? It's the last element, so you can have a r begin. You have a r begin iterator that will give you the maximum element, right? So maximum element is the last element in the set, so you can have that using r begin. It's order of one operation. Okay, let's talk about the third one. Delete elements, log of n in set. Okay, everything is log of n. Heap, insert log of n, max order of 1. Max is order of 1 in heap. Remember this, max element is order of 1 in heap, right? Because it's just the top element. Delete element, this is order of n. If you are deleting any element, it's order of n in heap. Only if you are deleting the top element or the maximum element, only in that case it's order of log n, right? Otherwise it's order of n in heap. So heap will not work. It will be order of n for these queries. So you have to use a set in this case. But if there are multiple such elements, you have to use a set or a multi-set. Like insertion can be multiple of these elements, right? So a set or a multi-set will be useful. Am I having mic issue? Can someone tell if I'm having mic issue? Can someone tell if my audio, if I'm audible properly, or am I having some mic issue? Okay, रुक जाओ, हो सकता है. Is it better now? Is it better now? Tadagati, is it better now? Just let me know. Now, okay, awesome. So what I'm saying is, for set, insertion is log n, max element is order of 1 because it's the last element. Delete elements is log n again. Heap, order of log n, order of 1, order of n. Delete is order of n. So you should use a set or a multi-set depending on if the elements are repeating or not. Okay, if the elements are repeating or not. Okay, so there is one more trick actually. There is one more trick. If you don't want to use a multi-set, right? Although it makes more sense to use a multi-set. In some cases you have to use multi-set, but in case you don't want to use multi-set because it's just the frequency, right? I'll tell you a trick here. Okay, if you don't want to use a multi-set, like just to maintain the frequency, like or like if you want to remove an element or these things, what you can do is you can maintain a combination of a set plus map. This is a very powerful combination, set plus map. This is very powerful. Why? With set you can store the unique values in a ordered fashion. With map you can store their frequencies, right? So let's say you are inserting an element x. What do? Set dot insert x and map of x plus plus. You do these two things. If you are deleting x, what do? you first do map of x minus minus. Now if map of x is 0, if map of x is 0, that means the frequency is 0. Only in that case you should do set dot erase x. Only in that case you should do set dot erase x. So this is a very powerful combination, a set and a map together. So in case you want to like not delete from the set, you don't care about the values to be repeating in the set. You are okay with unique values, but only thing that you care is you should not delete an element if it is still there, like if occurrences of it is still there. In those cases you can actually use a set and a map combination, and that will also help you, right? So this will be frequently used by you. I'm pretty sure it will be frequently used by you in problems. Definitely. Okay, let's come to the second question. The second question is, I'm not talking about what that if the condition in delete, why that if condition in the delete. Okay, let's say we are inserting something like this. If you are inserting like this 2 2 1 3, so what do you have in the set? 1 2 3. Now say you write a command delete 2, so 2 will be removed from the set, but you don't want it to remove because only one element is 2 of 2 is removed, right? So you want 2 to be there in the set. So if you're not using a multi-set and you only care about the frequency, like they should be in proper frequency while deleting, then what you should do is you should just maintain a set and a map, and you should just like not delete 2 right now. When you delete this 2 again, now 2 is gone completely, so the map will tell the frequency is 0, so then you should delete this 2. So that's why we have that if condition inside for like a set and a map. It just maintains the case that we should not delete all the occurrences of 2 when only one of them is deleted, right? Okay, let's come to the second question. Let's think about this a bit. Okay, a very easy question maybe. You have to, one second. Okay, you have to, what I have to do, A will be, you have to find maximum or find minimum element. Let's say find min element. The second operation that you have is insert element. The third that you have C is find or remove min and second min. Remove minimum element and the second minimum element. These are the three operations that you have: finding minimum element, inserting an element, and removing the min and the second minimum element. What should you use? Removing the minimum and the second minimum element. What should you use? Okay, Dharavi is saying set. Anyone else? Any other guesses? Set, map and set together. Okay, ordered set, sort of. Anyone else? Any guesses? Any more guesses? So we got set, we got map plus set, we got, okay, we got heap as well. Okay, we got heap as well. Let's look into them. Okay, we have got all of them, right? First, finding an min element, finding the minimum element. Set, the first element is the minimum element, so definitely okay. Heap plus set is also okay because you have removed elements, so definitely let's just consider them together, map plus set and set together, because if you have duplicate elements, definitely map plus set will help. Let's come to heap now. Minimum element is order of 1 again. Minimum element is order of 1. Insert element, order of log n in both cases. Remove min and second min. It's again order of, maybe it's order of 1. Okay, it's order of 1 because you are removing the first element, right? You are removing the first element and you have iterator to that element actually, so it's order of 1 actually. Heap, order of login, right? Heap will be order of login, although yeah, order of login, right? So definitely it makes more sense to use a set, but again, you can have all the operations supported in a heap, right? In set you have this one as login, c into login, right? We have the const, and see, remove mean and second mean element in heap. What do? We remove the top element two times, we remove the top element two times, that's all, right? Because we have a min heap, we are maintaining a min heap because we have to find the minimum element. So c into login, in case of set, in case of heap as well, it is c into login, c2 into login. But we know that c2 is much less than c. So when we can use a heap, we should always use a heap, right? So in this case, we can use a heap. It's okay for us to use a heap. So we should always use a heap. So that is how you decide like what to use. You just write all the things that you have to do in the problem, right? You just see what are the things that you have to do in the problem. Based on that, you decide what is the appropriate data structure for this. Okay, let's look into some problems now. Okay, let's look into some problems to understand better. So I think the first problem that we'll solve is actually a very good problem. Let's just try to solve this. Okay. Let's just try to solve this. Okay. So this is the problem. I'll just read. Let's just read this up. Yeah. Let's just read this up. So during the Indian programming camp, so this IPC camp that is being held, there are N trainers. Okay, there are N trainers. The camp runs for D days. The camp will run for D day. Each day there can be at most one lecture. So the camp will be running for D days. Every day there can be at most one lecture. The ith trainer arrives on day DI and then stays till the end of the camp. So the ith trainer is appearing on day DI and he will stay till the end of the camp, right? So just again, there each day it will last for D days. Each day there can be at max one lecture. For each of the trainers that are there, they will be appearing on some day DI that is given to us, and he will stay till the end of the camp. So from DI to D, up to D days, he will not up to D days, like whatever is the end of the camp, he will be staying up to that period, right? He also wants to teach exactly TI lectures. This lecturer also wants to take TI lectures. For each lecture that a trainer was not able to teach, he will feel sad and his sadness level will increase by SI. Let's say one lecturer wants to take 4 classes. He wants to teach 4 classes for 4 lectures. He is not able to take 2 of them. He is able to take 2 of them, but due to time constraint, he is not able to take 2 of them. So his sadness level, let's call it 5. His sadness level will increase by 5 into 2. Because for each lecture he is not able to take, his sadness level is increased by SI. So it will be 5 into 2 for 2 of them. So 10. Total increase in sadness level for this lecturer is 10. You are the event organizer, you have to minimize the total sadness of all the trainers. So you have to minimize the total sadness value that is there for all the trainers. Yeah. Okay, let's look into examples now. Okay, let's see the input first. N and D first. N lecturers D and then DTS. Okay. 2, 3. We have 3 days. It will last for 3 days. Okay, let's write it down here. 2, 3. So let's so there are 2 trainers. Let's write it down as day 1, day 2, day 3. The camp will run for 3 days. So day 1, day 2 and day 3. Let's see. So there are 2 trainers. The first trainer will come on day 1. He will come on day 1. He wants to take 2 lectures and his sadness value is 300. So the first trainer comes on day 1. He wants to take 2 lectures. His sadness value is 300. 300. Yes, Naveen. Naveen Kumar, please ask. The second trainer comes on day 2. He wants to take 2 lectures. His sadness value is 100. Second trainer comes on day 2. He wants to take 2 lectures. Sadness value is 100. हाँ बताओ ना, बताओ ना. So what is the minimum value of the sadness value that you can have? You have to organize them, right? So see, there can be multiple ways. See, first is on day one, only one of the trainers have come, right? Only first trainer has come. So trainer one will take on day one. On day two, both of the trainers are available. And trainer one still has one of the lectures pending. So we can give it to both trainer one and trainer two. So we can give it to both trainer one and trainer two. The third day, we can again give it to both trainer one. Like if trainer one is completed, we'll not give it to trainer one. If trainer one is not completed, we'll give it to like trainer one, right? So again, trainer one and trainer two, both of them. Let's look into one of the configurations. So let's say the second day is given to trainer one. The second day is given to trainer one. Sorry. Second day is given to trainer one. The third day is given to trainer two. In that case, what is the sadness value? In that case, what is the sadness value? See, trainer 1 taking 2 classes, so he is not sad. Trainer 2 is not taking 1 class, so he will be sad, and sadness value is 100 total. Let's say on day 2 we give trainer 2, on day 3 we give trainer 1 again. In this case again it is 100, the same thing. We give trainer 1 the first day, we give trainer 1 the second day, or trainer 2 the second day, we give trainer 2 the third day. So trainer 1 is not able to take 1 class. So the sadness value will be 300. Trainer 2 will not be sad. He is taking both the classes. So the minimum of them will be 100, right? So our answer for the first test case will be 100. Just see, 100, right? We can directly go to the third case. We'll directly go to the third case. How to improve in CF and CC. कॉन्टेस्ट तो मैंने बहुत बार बोला यार, कोई भी लाइक ए में देख लो, कोई भी ए में देख लो. आई हैव अ फ्यू ए में लेक्चर्स इन माय like in my under this playlist. So just look into one of the email lectures. I've discussed this many times. देख लो कैसे improve करना है. ठीक है, चलो let's go to the next one. ये वाला लेते हैं 3 to 150. 3 to 150. So 3 to 150 and 1 1 200. 1 1 200. Okay, 1 1 200 and 3 to 150. I give Neil Tharpa still newbie. हाँ देख लो. अरे मतलब you have to practice properly, right? So whatever problems you're not able to solve, let's say div to BC, just solve div to BC as many as you can, and definitely it will help you. Okay, you have to solve in a strategic way. So 3 to 150, 1 1 200. That means trainer 3 is available only from day 3. Trainer 3 is available only from day 3. Trainer 1 is available from day 1. So day 1 we'll give it to trainer 1, let's say. Now trainer 1 is happy, right? He has taken all the sessions. Day 2 nothing is left. Like no one is here. Day 3 we can give it to trainer 3. So what is the sadness value that we get? Trainer 3 is unable to take 1 class, so 150. And this is the only possible thing that we can do. 150 is the best we can go for. So the answer will be 150. Right, the answer will be 150. So this is basically the problem statement. Is it clear with everyone? Is it clear with everyone what is the problem statement? Then we can go into the solution for this. Or if you want to suggest some solutions, definitely you're definitely free to like suggest some solutions. But is the problem clear with everyone? Let me know if the problem is clear with everyone. Okay, good. So after an instructor comes, he can take some classes. He wants to take some minimum number of classes. We have and he has some sadness value. Our work is to minimize the sadness value, right? Our work is to minimize the sadness value. That's the question. Anyone wants to volunteer? Like, how can we solve this? Anyone wants to give some solution or suggest some solutions? Okay, sort according to sadness value field. After that, max heap of sadness value. Okay, after that, after that, also, why do we need a max heap? Can you tell? Because we can just sort, right? We can just sort and they will be in sorted order. Why do we need a max heap? Is there some advantage of having a max heap? Is it dynamic? Like, are we inserting elements? Are we deleting elements? Okay. Uh, anyone, like, what should we do after that? What should we do after that? Okay, let's actually discuss this. ठीक है, time waste करके फायदा नहीं है. So let's discuss this. Definitely, when you look into the problem, you are understanding you are definitely understanding that if, let's say I have a day, right? If I have a day, I have two instructors or maybe more than two instructors competing for this day. Like I can assign to both of them. I would prefer assigning to the one who has more sadness value, right? I'll definitely prefer to assign this day to one who has more sadness value. So definitely we will be following a greedy algorithm where we will try to start assigning by the ones having maximum sadness value, and we'll do it in that way, right? But let's understand the problem with greedy algorithm, right? Let's understand the problem. So what we are doing essentially, let's understand this. Let's say there is an instructor. He comes on day, let's say 5. He has a sadness value maximum of 500, right? And he wants to teach, let's say, for 3 classes. There is another teacher who, let's say, comes on day 2. He has a sadness value of 300 and he wants to teach for 5 classes. So what will be the problem here? If you're assigning them, what you essentially have to do is, let's start with the brute force algorithm. We'll start off with the first like maximum sadness value instructor. So he will appear on day 5. So from day 5 he will be getting the priority, definitely. From day 5, let's say this is day 5, this will be given to teacher 1. Day 6 will be given to teacher 1. Day 7 will be given to teacher 1. So this is definitely there, right? This will definitely happen because he has more sadness value. Now on day 2, second teacher comes in. So let's say day 2, day 3, day 4. The second teacher comes in. He wants to take 5 lectures. So he will start from day 2, teacher 2, teacher 2, teacher 2. 5, 6, 7 is booked up. So next available slot will be 8 if it is continuing, the camp is continuing. So again he can take from here, right, at 8. He can again take. So the brute force algorithm for this will be, I'm pretty sure you've got the idea, like this is how we'll allocate, right? So the brute force will be something like this, that we will just go through all the teachers, we'll just sort all of them with respect to their sadness values. So let me just write the algorithm for you. Just let it has frozen. Can I just use the tutorials point whiteboard? Maybe I'll just use this. Let's see if this works. Okay, so what we'll do here, the algorithm will be something like this. First of all, we'll sort all of the instructors. We'll sort all of the instructors with respect to their sadness values. in descending order. Now we'll go through all the instructor. We'll go through all the instructors one by one, like as it is sorted in descending value. We'll try to allocate them as much as possible. So for whatever is the arrival day, for let's call it I equals to arrival day of the instructor, right? And I less than d, I is less than d, like it will continue up to d, so I is less than equal to d, and I plus plus. So we'll check if it is booked or not. So if not booked, if we haven't booked the ith date for anyone, we'll book it, right? We'll just book this. So book I equals to true, we'll just book this day. And what we'll do is we'll also like sadness, the number of lectures will do minus minus. So the number of lectures he wanted to take, let's call that ti. So ti tj minus minus, or tj minus minus, something like this, right? So this will be the algorithm that will start with, will sort all the instructors with their sadness value. Then we will loop over all the days. We'll loop over all the days that are there. If the ith day is from the arrival day, we'll start from the arrival day. Now if it is not booked for that day, we will book it, and we'll also, this teacher is able to take a lecture, right? So we'll also decrease the number of lectures he wanted to take, or that is remaining basically. So tj minus minus, right? So that's the algorithm that will follow. But what is the complexity of this? The complexity of this will be n into d. Sorry, n into d. The complexity of this will be n into d, right? Can anyone optimize this? How can we optimize this? Is the algorithm clear with everyone? How we are solving this problem? Is it clear with everyone? How can we optimize this? How can we optimize? Batao? So just let me write it again. Let me maybe write the write it again. So I'll be sorting all the instructors, right? I'll be sorting all the instructors with their sadness values. So then I'll loop on the instructors. So j equals to 0 to n. I loop on all the instructors. Now, as arrival day, let's say it is giving in di. So for I equals to d of j to d, from d of j to d plus 1, rather d plus 1. That is, this is will not go up to this much. So d plus 1 will check if it is booked. If booked, if not booked, if it is not booked, if not booked if ith day is not booked, we will make it booked. So booked of I equals to true, and we'll also do t of j minus minus. That is, he is able to take a lecture, right? So t of j minus minus. And finally, what we should do, whatever like sum, after this is done, sum plus equals to t of I into s of I. This is what we should do, right? After this entire thing is done. So this is the algorithm. What is the complexity? See, outer loop is running from n, inner loop is running for d. So it is n into d, right? How can we optimize this? Very simple. How can we optimize this? Just think about this. How can we optimize? Or what is actually causing the complexity to increase? What is actually causing the complexity to increase? Why is the complexity increasing? N plus 1, n minus 1 tak, matlab, let's write it like n minus 1, and let's write it here up to d. I think that will make more sense. Hash map to store days. Okay, but how will that help? Why would that help, and how would that help? Okay, let's understand, right? The problem here being we are visiting a day again, although it is given to another teacher, right? So this is what is preventing us from booking, right? But again, booked of I, this ith day is already booked by someone else, we are still visiting. So that is actually adding to our complexity. What if we have a data structure that can maintain the current set of days that are pending, that are not booked by anyone? It just maintains the current set of days that are not booked by anyone, and we just book from there. We just book some dates from there. We use the same algorithm, but now what we are iterating on is not from d of j to d, but rather from in we are rather iterating on the current set of days that are remaining, that is not booked by anyone. So just think about this, the inner loop, then it will turn out what? Total of d, like over all values of n, it will be total of order of d, because you are taking a day once you are taking that day, you are never revisiting that again, you are just removing that from your data structure, right? So that will become order of d, and total complexity will be order of n plus d. So how can we, is there a data structure that can support addition, removal, as well as, like, it will store it in an ordered fashion and also finding the next possible day? We have something called a set that does exactly this, right? And in fact the days are unique as well, so we don't care about like multiple occurrences of the same day. So we will use a set for this. I'll write the code for this, and I think that will make much more sense like when we do this, right? So let's just look into the input ones. Okay, ndt. So what we'll do is, let me just create a new file. IPC trains. Let's see. I'll just close this for now. So what do we have? We have we can take input as well, right? We can take input as well, but let's just take it from like this, like n and d. So we will just have, first line will have t. Okay, t is the number of test cases, so let's just have t first. So in t in t while t minus minus. After that we'll have n and d. So in nd, scene nd, number of days and number of instructors. Now we will store the instructors like this: paired int int, and instructors, right? So the paired int, this value will be stored something like, the sadness will be stored first. The sadness will be stored first. After that let's store them like d and t, like this, something like this. So this is how we'll be storing them. This integer will be the sadness, because we'll sort by that. After that we can store d and t, what is the day he's arriving versus what is the number of lectures he wants to take. So pair intent instructors, and for int I equals to 0, I less than n, I plus plus, and it will be of size n, right? It will be an array of size n. So I plus plus instructors. So scene, how will be the order? The order will be dts. So scene, let's just define a few things first, just to make things cleaner. Hash define f will be first, hash define s will be second, right? So c in first will take instructors I dot second dot first, instructors I dot second, and finally we'll take instructors I dot first. So instructors I dot first. Okay, I think that is the order DTS. That is how it is given. DTS, right? This is the order in which it is given. So we'll take like this, right? F first, second dot first, that is D. Second dot second, that is T, and then first, that is S. Okay, now we'll sort it. We'll not write any comparator function for now because we can just run a loop in a reverse way. So instructors plus N. Okay, now what we'll do is we'll place, so we'll take the days, right? We'll take the days set of days. So for int I equals to 1, I less than equal to D, I plus plus, days dot insert I. We'll insert all the days that are there, right? Now what we'll do, we'll loop over all the instructors one by one. Now it is arranged in ascending order. We'll go from reverse, I greater than equal to 0 and I minus minus. What we'll do is, first of all, we want to find what is the first day. What is the, just think about this, what is the first day that has not been taken after the current instructor is arriving? What is the first day that has not been taken after the current instructor is arriving? That is where we should start at. So auto it equals to, we have something called lower bound, right? So days dot lower bound, what? It will be lower bound of instructors. It will be lower bound of instructor I dot second dot first, right? That is the day. It will be lower bound of day. Now we'll move up to where? While it not equals to days dot end, we'll iterate up to there. What we'll do? Instructors I dot second minus equals to 1. And we'll also do it equals to days dot erase it. We'll erase this data as well from the set. Days dot erase it, right? Finally, what we'll do, answer equals to 0. For int I equals to 0, I less than n, I plus plus. Answer plus equals to instructors I dot first, that is the sadness value, into the time left, right? So instructors I dot second, how many classes he wasn't able to take, right? So second dot second, and see out answers flashing. Okay, is this clear with everyone? How is this code working, or what is the complexity? Just look into this part, right? You are erasing the days, so it's not order of D anymore. You are just visiting a day once. Every day you are just visiting once. What is the total complexity over all the loops? It will be, you are visiting at max D days, so it will be order of D over all the entire loop. So it will be order of n plus D, right? It will be order of n plus D, the total complexity. And definitely there is n log n here, so n log n plus D, because you are sorting, right? So that's the complexity. We can try submitting this definitely, but it will anyways work, right? So let's just not waste time submitting this. Maybe we can run it on the sample case. Let's see if it is working, just to check if it is working. So what we can do, we can go to submit. I should have actually checked on not here actually. Okay, maybe I should just go ahead with submitting. Okay, let me just see if this compiles first quickly. If this compiles, then it's fine, I believe. Okay, I think it compiles, so let's just stop this for now. Use this, and let's run this. Okay, we can give sample case as well, right? What was the sample case? We'll take one test case, and in the test case we'll take, let's say, 2 instructors. We'll continue the camp for 3 days. The first instructor appears on day 1 with 2 and let's say 300, and the second instructor comes on day 2 with 2 and 100, so it should give us 100, right? So let's just see if it gives us 100. We are getting minus 100 for some reason. Why did we get minus 100? Okay, so definitely it's not correct yet. Let's see. Instructors is okay. We have to add a case here, right? That it should not be given, like he should not be given everything. So and instructors of I dot second is greater than 0. As long as it is greater than 0, I should continue subtracting. So that's something that we have missed, because like we should make sure that he's not given more days than he actually needs, right? So that's the only condition I think we have missed. So I think now it will work, and we can submit and check as well, like it will definitely work. Is this clear with everyone? What is the complexity? What is the, like, how is it working and everything? Okay, it might fail because of long int issues, but it's just... anyways, is it clear with everyone? Is it clear with everyone? Wrong answer because of long integer issues. We can just convert this to, we can just do something like this, as defined in long, and we can go for signed main. I think that should be the issue. Yes. Can you explain that defined part? Yes, I'll do that. Let me just check once. It should be okay. Defined part, coming to the defined part. Where is that? Okay. So what we have done here is we have defined f to be first. So when you are using a pair has two elements, right? Like pair int in, let's say we write it like this, pair int x. So the first element we can write it like this, x dot first. Instead of that, I'm writing x dot f. X dot f, it will get replaced by first automatically, right? Similarly, x dot s, it will get replaced by second automatically. So just to make the code shorter, I have defined these two things, that first should be called f, second should be called s, and that's why I'm able to use them like this, second dot first, second dot second, like this. S means second, f means first. Yes, now it's working, right? Cool. Anyone has any doubts with this, or otherwise we can go to a new question actually. Maybe let's go to a new question. I think it's clear with everyone. Is the complexity clear, like why it is order of t? I think that's what we should do. We should do this for now. After this, we'll move to the sliding window maximum. I think that will take some time. So we'll just directly move to that. Okay, otherwise let's just do that first and then come to this, or the other way. Anyways, we can do this first. Time complexity, sure, I'll do that again. See, although it looks to you that we are actually going through order of n into d, right? Because inside this there is another loop that's running. But just look into this. We are going through this. This is order of n definitely. What is the total complexity of this? See, when we are looping over all the days, right? We are looping over all the days that are valid days, and we are removing them from the set as well, right? Let's just say in the first iteration, so we have the days initially as 1 2 3 4 5. In the first iteration we delete 3 and 4. So in the second iteration we only have 1 to 5. Let's say we delete 2 and 5 in the second iteration. In the third iteration we only loop over one element. So in total, we are only looping over the total number of days that are there. We are not looping, and for each day we are just visiting it once. If we are visiting that day, we are also removing that day. So each day is visited just once in all the loops, right? In all possible loops. What is the total complexity over all the loop, the entire loop, I equals to n minus 1 over all these loops? What is the total complexity of this inner loop? It will be order of d, right? Because each date is visited only once in the inner loop and it is not visited again. So it's order of d over all possible loops of the outer loop. So that's why it is order of n plus d plus n log n because of sorting. Does it make sense? Does it make sense? You are not visiting a day more than once, right? Just think like that. You are not visiting a particular day more than once. So that's why total number of days that are there is d. So it's never more than order of d. So sometimes, yes, you have to write loops like this, right? You have to write two loops, but two nested loops doesn't mean it's order of n squared or n into d, right? You have to identify what is the total complexity of the inner loop with respect to all possible outer loops. If it is order of d, that means it is order of n plus d overall. Okay. Chalo. Before we go ahead with this, let's just do the sliding window maximum one, because that's something that I've already said I'll do. So let's just do this. And these are the two last problems. Let's just complete our class with these two problems. Okay. Chalo. The question is pretty simple actually. I think you guys already might know about how to solve this, but again, let's just discuss in case you don't know. So this is definitely tagged as a hard problem, but like if once you know the solution, it's a simple, like easy solution that you have to write. So you are given an array of integer nums. There is a sliding window of size k, which is moving from left to right of the array. You can only see the k numbers in the window. Each time the sliding window moves right by one position, return the max sliding window. That is, initially, see, initially you can look into the explanation like this. Initially the window is of size 3, right? K is 3, that is the window is of size 3. Initially it is covering the first 3 elements. What is the maximum out of them? 3. Now the window is moving to the right by one position. So 3 minus 1 minus 3. What is the maximum element? 3 again. So 3. After that, the window is moving by one position. Minus 1 minus 3, 5. What is the max element? 5. So 5. After that, the window is again moving by one position. So minus 3 minus 5 and 3. What is the max element? 5 again. Again, the window is moving by one position. 5, 3, 6. What is the max element? 6. After that, it is moving to 3, 6, 7. Sorry, 3, 6, 7. So what is the max element? 7. So it is reporting 7. So this is the output that you have to report, right? 3, 3, 5, 5, 6, 7. So you are given a sliding window. What is the maximum element over all the windows? You have to return that. Okay. Is the question clear with everyone? Is the question clear? What does the question demand? It's pretty simple. Like the window is just sliding and you have to tell what is the maximum element. On 3 minus 1 minus 3 5 3 minus 3 5. Six, 7. Okay. I think the question is clear. I'm not repeating the question again. Okay. I'm not repeating the question again. Let's understand how do we solve this. Okay. The problem, like if you just want to maintain the maximum value, right? The problem will be you might lose some information, right? Maybe let's just modify this array to understand what the problem is. So let's make it minus 2 instead of 5. Let's make it minus 2. So see, if we just maintain the maximum element, what will be the problem? The problem will be, first of all, we are at 1 3 minus 1. The maximum element is 3. When we move to 3 minus 1 minus 3, the maximum element is still 3. But when we move to minus 3 minus 1 minus 2, the maximum element becomes 1 minus 1, which is actually lost because 3 was the maximum element in the first window. So definitely if you are maintaining like this, you will lose information. So you have to maintain minus 1 as well somehow. in an optimal way, definitely in an optimal way. What can we do for this? What we'll do is actually tricky. What we'll do is we'll maintain a DQ. Why do we need a DQ? We'll understand that in some time. But let's say we are maintaining a DQ. This DQ contains possible values of candidate maximum. That is, at some point of time, this can become the maximum element of any window. At some point of time, this can become the maximum. Right? There is a chance that this might become the maximum for some window. You will maintain those elements. Right? So this array, if you just look into this DQ, how should this DQ look like from left to right? This DQ should be a maximum a decreasing DQ from left to right. A decreasing DQ from left to right. Why? Can anyone tell why should this DQ be decreasing from left to right? Just think about next greater element and stacks. What did we say? The stack was increasing / decreasing in one direction. Similar concept will apply here. Why is the DQ decreasing in one direction, from left to right? What does this DQ contain? It will contain possible maximums for future, or possible values that can be maximum in future. And I'm claiming that with this thing, the DQ should be decreasing from left to right. Can anyone tell why? The DQ should be decreasing from left to right. Why? Why should it be decreasing? That's the question. Can anyone tell? Why should the DQ be decreasing from left to right? Just think about this. Why should it be decreasing? Why should the DQ be decreasing? Okay, let's understand. Why should it be decreasing? Okay. I am saying let it not be decreasing. Let it not be decreasing. So there is a P. After that there is a Q, and it is not decreasing. That means let's say Q is greater than P. I am saying Q is greater than P. Okay, one more thing that I forgot to tell. In our DQ, we'll be inserting from back. So we will be inserting from back. This is also needed. Now, if we are inserting from back and Q is greater than P, that means what? Q is coming after P. Q is coming after P, right? Q means Q is on the right hand side of P. P is somewhere here in the array. In the array, P is somewhere here, Q is somewhere here. Now, both P and Q are in the current window. Definitely, both P and Q are in the current window. And Q is greater than P. Can you tell me, can P ever be the maximum in the future? Can P ever be the maximum in the future? Just think about this. Can P ever be the maximum in the future? You have the array like this. Let's say this is the current window. The array window will shift, right? So P is on the left. So P is the first element to be going out in some window. So P is the first element. Sorry. P is the first element to be going out of the window, and Q will still be there from now. From this point, Q will still be there because Q have been inserted into the this Q has been inserted to the DQ. That means P can, and Q is greater than P. So P can never be the maximum, right? From now, this point, in the till the future. P can never be the maximum. So that means this is not valid because it contains a value that can never be the maximum in the future. But we said that the DQ should contain possible values that can be maximum in the future. So this gives a contradiction. So definitely it shall never be the condition. So our DQ should be decreasing. Our DQ should be decreasing. Okay? And that's it. That's it. If we are able to maintain this decreasing DQ, we are done with this problem. Let's understand. Let's understand this, right? Let's understand. Chalo. Let's see the state of the DQ at any point of time. How should we do this? Now see. First of all, we have 1. So 1 is pushed from the back. So 1 is coming here. Now we have 3. We are at 3. We have 3. Whenever we are pushing 3, we should see it is decreasing from the back, right? It is decreasing like this. So it is increasing this direction. We will remove those elements that can never be the maximum. So we'll get them from the back. We'll get them from the back. So we'll remove those elements that can never be the maximum. So to remove those elements that can never be the maximum, what we will do is we'll go from the back. On the back, there is only one element, 1. Is 3 greater than 1? Yes, 3 is greater than 1. So definitely 1 can never be the maximum. So we'll just insert 3 here. We'll just remove this and insert 3 here. Okay. Now we go to -1. From the back, we will start. Is 3 greater than -1? 3 is not greater than, 3 is definitely greater than -1. So we will not remove 3. We will insert -1 into the DQ. Now we will go to this. Now see, we are done with one window, right? We are done with one window. Whenever we are done with one window, we will look at the front element. If the front element is equals to the element that is going out, if the front element is equals to the element, or we can actually maintain index here. We can even maintain index here, right? So for now, let's just maintain this. But in actual problem, we'll maintain the index, right, of the element. So if the index is equals to the element that is going out, or the element is equals to the element that is going out of the window, we should remove it from the front. So that's why we need to have a DQ. We are inserting from the back, we are deleting from the back, and we are deleting from the front as well when the window is going away, right? So that's why we need a DQ. -1. Okay, for the first window, definitely we know the answer is 3. So we'll write the 3 to be the answer for the first window. -1. Okay, now -3 is coming in. -3 and -1. Is -3 greater than -1? No, right? So -3 will be just inserted into the DQ. It is a possible value of maximum, but -1 is still possible, right? We'll now move out of the windows. Now see, we are moving to this window, right? 3 is going out of the window. The element that is going out of the window, is it the first element? Yes. Actually, we'll maintain index here just to prevent, if like let's say there are multiple occurrences of 3. So just to prevent those cases, we'll maintain index directly. But the element that is going out is equals to the element that is going out of the window is equals to the front element. So that it is going out of the window. It is no longer the maximum. So we will remove it from the front. We'll remove it from the front. Now we'll continue. -1. Okay. -2. -2 and -3. -2 is greater than -3. So -3 will be removed from this. -2 and -1. -1 is greater than -2. So -2 will just be pushed into the stack, into the DQ. Now for the second, it is -1 is the answer. For the for 2, 3 is the answer. For the third, -1 is the answer. Now we are again moving out. We are again moving away. So now -1. See, -1 is moving away. It is coming here. This is the window. -3, -2, 3. -1 is moving away. Is the front element equals to -1? Yes. So we'll remove that. We'll remove that from the front. So -2 comes to the front now. Okay. Now we have 3. Is the incoming element 3 greater than -2? Yes. So -2 can never be the maximum again, because we have 3 already in the current window. In the future windows also 3 will also be there, as long as -2 is there. And -2 will be removed first from the window. So definitely 3 will always be the maximum in such windows. So we'll remove -2 from this DQ and we'll insert 3. The answer will be 3 for the next window. Now we are going to 6. Now see, -3 is getting removed. So we check if the front element is equals to -3. It is not. So we don't do anything. 6 is getting inserted. Is 6 greater than 3? Yes. So my 3 will be removed. 3 will be removed. It is no longer a value of candidate. It can never be the maximum again, right? So 3 is removed, and we will have 6 here. We will have 6 here. So we will tell the answer to be 6 now, right? Like this, it will continue. So are you getting the idea? Are you getting the idea? So this is how it is happening, right? Let's write the code for this to understand, like then we'll talk about the complexity and stuff. Are you getting the idea about how should we do this? Let me know if there is any doubt with this logic, right? Okay. So what we'll do is we'll maintain a DQ, right? So DQ int, let's call it DQ. Okay, for the first window, first of all, we'll cover for the first window. So let's keep the vector int answer. Let's cover for the first window for int I equals to 0, I less than k, I plus plus. So while not dq.empty, while the dq is not empty, so dot dq.empty, and dq.back, the element at the end, is less than the element that is coming in. It is less than equal to the element that is coming in. So the element that is coming in is current element, that is nums of I. In that case, what we should do, dq dot pop back, we should remove that element, right? Now we should do dq dot push back, definitely push back nums of I, nums of I. And for the first window, we'll push the answer dot push back. What is the answer? Always the answer is the front element in the dq. So dq of 0 or dq dot front is the answer always, dq dot front. Let's now do a sliding window. Let's now go for a sliding window. So for int I equals to, we'll go to the second window, I equals to k. We'll just go through the ends, right? Window ends for each of them. I equals to k. The last possible window will be nums dot size minus 1. That will be the ending point. So we are going through all the possible ending points of the next windows, I plus plus. What is the element that is going out? Okay, first thing to note here, we have done wrong is this should be nums of, we should store the indices, right? We should store the indices. Nums of dq dot back is less than equal to, and dq dot push back should be this one, I, and this should be nums of dq dot front, nums of dq dot front. That should be the answer. Now if the element that is going out, that is I minus k, right? So if dq dot front is equals to what, I minus k, in that case we should do dq dot pop front. We should do dq dot pop front. We should remove it from the front. Now okay, now we should insert this current element. So we should insert the current element that is coming in. So again, we'll run a similar loop like the previous one, while not dq dot empty and nums of dq dot back is less than equal to the element that is coming in, nums of I, dq dot pop back. And finally we'll do dq dot push I. And what do we push in the answer? Answer dot push back, sorry, not push, it will be push back. And the answer dot push back is nums of dq dot front, nums of dq dot front, and we'll do return answer. So this will be our answer. Now what is the complexity for this? That we have two loops. Again, we have two loops, right? So definitely you must be thinking this is n square, right? We have two loops, but again, just think about this carefully. Every element is inserted into the dq once, and every element gets removed once. Once it is removed, it is never inserted back. So the total complexity across all the loops will be order of n. It will be order of n across this entire loop. So the total complexity of this entire code will be order of n only, right? It will not be n squared. It will be order of n. So we can just do the run code and then we can submit this and see if this is working. Is this clear with everyone? How is this working? Or why is it order of n complexity overall? So we are done, I believe. Let's see. Okay, it's success, right? Is everyone clear why is this working and why is the complexity order of n? Is this clear how to solve this problem? So this is only the use case. This is, I think, the only use case for DQ properly, like uh, sliding window maximum or minimum. Is this clear with everyone? Let me know if it is not clear with you. Okay, let me know if it is not clear with you. Also, I'll give you a homework. We don't have time to do this, but definitely I'll give you this homework. What you have to do, just like maybe you can do it, find a separate question, but again, what you have to do is you have to find the minimum of a data stream, of an incoming data stream. Like the array is not fixed, right? You can add elements, and you have to report the median as well, right? So median is the element that is present in between the array in a sorted fashion. If the array is sorted, what is the middle element of that array, right? So you have a dynamic array and you have to find a median for that. So one hint that I will drop for you is you have to use two, whatever data structure or whatever STL container that you choose, you have to use two of them. So just think about all the operations that you need to do. If you are maintaining two of them, how should you maintain them? And what are the operations that you should do? And based on that, you have to judge what is the data structure or the container that you should use. Okay. So that is how you will solve this problem. Just take this as a homework maybe. Okay. And I'm hoping that this sliding window is clear with everyone, and you can get it done like whenever you have whenever someone asks you this type of question, you can get it done. I hope that this is clear. Okay, so take that median in a data stream as a homework. Okay, try to solve that. And yes, that's the end of today's class. If you have any doubts, you can let me know. Otherwise, yes, we are done with today's class. Tomorrow we'll be meeting for React class. We'll be doing some small project. Let's see what we can do. But yeah, like we are done with. Let me know if you have any questions for me. Okay. If you don't have any questions for me, let's end the class here, and thank you guys for joining in. Okay. Do the homework. Try doing the homework. If you can't, I'll definitely try to help you out. But try doing that. Okay. Chalo, I'll see you guys tomorrow in React class where we'll do some project. Let's see what we can do. Good night and thanks for joining.